Hey everyone, today we'll be going over buffers again. Well, there's just one type of buffer problem I think is important, and it's really difficult, so I thought it's important to go over. So let's get this started. So this time you want to calculate the pH of a 1-liter solution of 0.5 molar acetic acid and 0.5 molar sodium acetate after 0.01 moles of solid sodium hydroxide is added to it, and I forgot to write the Ka for this, so I'll just write it down right now. Okay, so this problem is kind of hard because you have to take the sodium hydroxide into account now, but it all becomes easy once you memorize one thing, and that's that when OH is added to a buffered solution, it's gonna react essentially to completion with the weak acid present. So in other words, the hydroxide is going to react with the weak acid to form the weak acid's conjugate in H2O. And yeah, the OH is going to react to completion. So I'll demonstrate what that means by actually applying this principle to the problem. So our OH is going to react with our acetic acid, which is, I think it's this, yeah. And then it's going to react with the acetic acid to form acetate ion and H2O. So the problem states that 0.01 moles of solid NaOH is added to it. Okay. So, oh yeah, so it's just an ice problem really. So it's just gonna start off as 0.01, and then this is going to be 0.5. It's 0.5 as well, and that doesn't matter. So it's going to react into completion, so all the hydroxide is going to go away. So, yeah. And that doesn't matter. Okay, so now we're looking for the equilibrium. So that's going to be 0, 0.49, and 0.51. So in summary, the acetate reacted with the weak acid to form more of the conjugate. So that's why the concentration of the weak acid is now less, and the concentration of the conjugate is now more. And we're going to use these concentrations to calculate the pH. So, yeah, well, I'll just write, shoot, I don't have enough room to fit this in, so I'm just going to write these concentrations down. 0.51, and I'll erase it. Sorry, this eraser is kind of small. It's gonna take a while. Oh, shoot. Okay, there we go. Yeah, so if you just remember that the hydroxide reacts to completion with a weak acid to form its conjugate in water, you're good. So now it's just a regular buffer problem. So we have our acetic acid, and that's going to dissolve into H plus and acetate. And remember that we want to use these concentrations right here. So let's make our ice table. So it's going to be 0.49 here, it's going to be 0 here, and it's going to be 0.51 here. It's going to decrease, increase, increase. Now we have our equilibrium. And we know our Ka, so we're good to solve. Almost there. Almost there. So, yeah. And we divide that by 0.49x. Okay, fortunately, x is going to be really small, so we don't have to multiply all this crazy stuff out. We can pretend that these x's aren't here. And now all we have to do is solve this relatively simple problem. And you get that x is equal to 1.7 e to negative 5. And now we just plug that into the pH solution, the pH formula. pH is equal to negative log of H plus ion concentration, and let me think this. What's it gonna equal? That's gonna be equal to around 4.76, and there we go. So yeah, I hope you felt good about solving this problem. It's a respectable problem that is kind of hard, but all you have to remember is that the hydroxide is going to react to completion of the weak acid to form more conjugate, and yeah, that's the secret to these kind of problems. So I hope you enjoyed the video, and have a good night or a good day, and see you later.